These are the notes for lesson 4.3, Determinants and Cramer's Rule, and this is part 1 of lesson 4.3. So we're finding the determinant, and the determinant is a real number associated with a square matrix. Remember, square matrices are 2 by 2s, 3 by 3s, so they are square because they have the same number of rows, same number of columns. We can use the determinant to find inverses and also to solve equations. So the notation for a determinant, the brackets are what we use for matrices. The straight lines right here are what we use to denote that the determinant is to be found. So think of these as like absolute value signs between the matrices. So again, the straight lines denote that we are finding the determinant. So the 2 by 2 determinant, we're finding the difference of the products of the entries on the diagonals. So remember, difference means that we are subtracting, and the product means that we are multiplying. So we're multiplying the numbers on the diagonals and then subtracting them. So to find the determinant of this first matrix here, again, we're multiplying the diagonals. So here we have A times D, or AD, minus BC, or B times C. And that will get us our determinant. So example 1, we are finding the determinant. So again, we are going to multiply our diagonals. So first we're going to multiply 4 times 1. And we're subtracting from that 2 times negative 3. So 4 times 1 is 4. Minus 2 times negative 3 is negative 6. We know that subtracting a negative is the same as adding a positive. So this is a positive 10. So the determinant of this matrix is 10. Now for a 3 by 3 matrix, we are doing the same thing, only there's one extra row and one extra column. So if you think about it, we're going to take our first number here, A, and we're going to multiply that times the difference of the two products on the diagonal here. And we're going to do that with A, B, and C. So one way of writing the determinant of a 3 by 3 is A times the quantity E times I minus F times H minus B times D times I minus F times G. Again, subtracting those products. And then lastly, we're going to add C times D times H minus E times G. So that is basically the formula for finding the determinant of a 3 by 3. Now there's a faster way of doing this. So if we again have this matrix here, again the straight lines mean that we are finding the determinant. What I want you to do is take the first 2 columns and I want you to rewrite them to the right of our last column here. So we have A, D, G, and B, E, H. So again, this is the first column, just rewritten, and the second column rewritten. Now this just makes our multiplying and finding our products a lot faster and easier. So now what we are going to do is, on the diagonals, we're going to multiply. So we have A times E times I, and we're adding to that our second diagonal. So B times F times G, plus our third diagonal, C times D times H. And we're subtracting that from the diagonals the opposite direction. So C times E times G plus A times F times H plus B times D times I. And again, that will get us to the determinant as well. And if we use the distributive property in this equation here, we'll end up with this second equation that we talked about. Example 2 says, given the following matrix, find the determinant. So again, when we have a 3 by 3 matrix, we want to look at the diagonals and multiply them. So the first thing we need to do is rewrite our first 2 columns. So we have 4, 5, and 1. 3, negative 7, and negative 2. So again, we're going to multiply the diagonals. So we have 4 times negative 7 times 2, plus 3 times 0 times 1, which we know is just 0, times 1 times 5 times negative 2. And then we are going to subtract the opposite diagonal. 1 times negative 7 times 1 plus 4 times 0 times negative 3, which again is 0, plus 3 times 5 times 2. Now we just need to simplify. 4 times negative 7 times 2 is negative 56 plus 0 plus 1 times 5 times negative 2, which is a negative 10. Again, we're subtracting. 1 times negative 7 times 1 is just negative 7 plus 0. 3 times 5 times 2 is 30. In our first parentheses, negative 56 plus a negative 10 is a negative 66. And negative 7 plus 0 plus 30 is 23. So if we subtract these, we get negative 89. So again, whenever we are finding the determinant of a 3 by 3 matrix, we first want to write those first two columns again, and then we're going to multiply the diagonals and then subtract them. We can use matrices to find areas of triangles if we are giving the vertices. So example 3 says to find the area of a triangle with the given vertices. Now we could plot these points on a graph. We could find the distance from the points, or we could, and then find the area. Or we could use the distance formula and find the distance between the points, and again find the area that way. Or we can use matrices. Now if you remember, the area of a triangle is 1/2 base times height. So we're going to use a similar formula using matrices. So to find the area using matrices, we're first going to multiply either a positive or a negative 1/2. Now the positive or negative just has to be the appropriate sign in order to get a positive solution. We know that the area is always positive, so whatever our answer is with our determinant, we're going to multiply that by either a positive or a negative 1/2, depending on which we have. So again, we want a positive solution, so that will determine what we multiply by. Then to get the base times height part of the formula, we are going to take the vertices and put them into a matrix. So we're going to take our x values, and that's going to make up our first column. So x1, x2, x3. Our second column is our y's, so y1, y2, and y3. And our third column is just 1's. Now if we find the determinant of this matrix, multiply that times 1/2, that will get us the area of the triangle. So let's go ahead and do this example. So again, our first column is our x values. So we have 1, 6, and 4. Our second column is our y values. So we have 2, 2, and 0. And our last column is our 1's. Now remember, we have to find the determinant of this matrix. So we want to rewrite our first two columns. So 1, 6, 4, 2, 2, and 0. Now to find the determinant, we want to multiply the diagonals. So we're going to start with 1 times 2 times 1. So again, we still have plus or minus 1/2. We're going to multiply 1 times 2 times 1 plus 2 times 1 times 4, because that's our second diagonal. And our third diagonal is 1 times 6 times 0. We know anything times 0 is 0. And we're going to subtract that from our other diagonals. So we have 1 times 2 times 4 plus 1 times 1 times 0, which again is 0. And lastly, we have 2 times 6 times 1. Now we just need to simplify. Again, plus or minus 1/2. We have a 2 plus 8 plus 0 minus 8 plus 0 plus 12. So plus or minus 1/2. 2 plus 8 plus 0 is 10. Minus 8 plus 12 is 20. That's going to give us a negative 10. Now remember, we want a positive solution because area has to be positive. So we need to multiply by either negative 1/2 or positive 1/2. To get a positive solution, we're going to need to multiply by a negative 1/2. So negative 1/2 times negative 10 gives us a positive 5. So the area of this triangle with these given matrices is 5. Again, we could have used multiple different ways to solve, to find the area, but matrices are just one of those other methods that we could use.